like with every limit from the very beginning, so every limit from the very beginning of the class, we need to know what's happening here. So first, let's analyze the square root of x. Where is this going when x approaches infinity? That's our first question.
Infinity.
Excellent. Now forget about this, and please tell me, where's my other prop? Here's my other, no, it's too big. I had two erasers here, and one of them disappeared. No, it didn't disappear, it was right here. So just tell me, where is this going when x approaches infinity? Anyone?
Negative infinity.
Thank you very much. You're just trying to torture me? No, I'm just kidding, I'm kidding, I'm kidding, I'm kidding. So now I would like someone to tell me, where is this going? In other words, I'm asking, where will e to negative infinity go?
Infinity.
I have,
Yes, negative infinity. Sorry.
hold on. So I have a cake or $1, and I want to share it with 11 billion people. How many are we? Are we 10 billion now? I want to share it with everyone. When I get to your door, how much will you get from my $1?
Not much.
Of course not. So 1 divided by huge. I'm not really allowed to write this. Okay? So disregard it. I had to explain what I'm doing. So e to negative infinity is 1 over e to infinity. This is a huge number. If you divide 1 by a huge number, you get approximately 0 or 0. So now look what we have. What is all this? Well, it's 0 times infinity. So this is a product called indeterminate product, right? So what do I do with this? So in general, I'm not saying that this is a recipe, but in general, a simple algebraic for the product, indeterminate product, simple algebraic manipulation is going to do the trick, is required. So I realize that this is 0 times infinity. I know this is the only indeterminate product. A simple algebraic manipulation will normally do the trick. So let's take a look again. I'm going to copy it here. And tell me, how will you think to manipulate this? Manipulate, by manipulation, I mean changing it into something that it equals to. I cannot change the function. I can change the outlook, the presentation. How will I change the presentation? Any suggestions? What would you do? And what is really the only thing I can do? What do you think? And this is something like we always do. We always remind ourselves, don't leave this there, don't leave it there, don't leave it in the final answer. What will that be?
We change the format of x. I don't know if that would make a difference, but would it make a difference to change x to x times? I mean, x, change that to a power. So no.
What is the other way of writing this?
Can you take the derivative?
I'm not allowed to. What is the other way of writing this?
Would you make it a natural log?
Nope, I cannot do that.
So just make it 1 over.
Thank you very much.
1 over
E to x over 2, of course. We always know that a negative exponent is a fraction. It's 1 over. Awesome. Now let's see again what we have. Where does the numerator go when x approaches infinity? I already have
Infinity.
it here. Right, I already, good. Where does the denominator go when x approaches infinity?
super small. No. Infinity.
Of course. You like it? That's all I needed. Why? Because now in this condition, what can I do?
So now we can just use the prime, get the primes.
That's it, L'Hopital's rule. Okay, exactly. So we change this with a simple algebraic manipulation. We change the product for which we cannot apply the L'Hopital's rule. We change it into something we can apply L'Hopital's rule on without changing the function. This or this function or this function are identical. Good. So can anyone give us the derivative of the top?
1 over 2 of x.
Very good. Can anyone give us the derivative of the denominator? You know we never differentiate like this, right? Please don't get confused. We have a limit of a ratio that has infinity over infinity or 0 over 0. That's why we do this. I'm not allowed to differentiate a ratio outside of a limit like that. So don't get confused. This is allowed only for several reasons. Number one, this is a limit. Number two, this is a fraction. Number three, it's 0 over 0 or infinity over infinity. Good. The denominator prime.
E to the x over 2 times quotient rule here, I guess.
No, we differentiate x over 2.
1
Over
over
0, right?
So when we differentiate x over 2 is the same with 1/2 times x.
Okay. So it's x over 2. Wait, hold up. Say that again. So
X over 2 can be rewritten as 1/2 x. Can you differentiate this? Anyone?
Half.
That's it.
So 1 over 2.
Good. So now let's rearrange and see what happens. The numerator, so I copy the limit as x approaches infinity. The numerator is 1 over 2 the square root of x. The denominator is this over 2. I will flip 2 over e to x over 2. I will simplify. And now I try again. Where does the numerator go?
One.
Good. Where does the denominator go?
Infinity.
Good. What do we say about 1 over infinity? I have $1 and I want to share it with everyone on the planet when I get to your door.
small.
How much?
Very
Good.
small.
That's it. Which means y equals 0 is also a horizontal asymptote at infinity. And you could say, like sometimes my students say, well, didn't I tell you? 0 times infinity is 0. No, not that fast. It just happened. Good. Good pick. Thank you. Let's choose more. So we had something with e to the x. Maybe we want to look at eventually, something like this I would like to look at. But definitely we have to reach these. These are the most complicated ones, the powers. Not the product, not the difference. the powers are the most difficult ones. The product is quite nice. As long as I find a manipulation or just rearrange the function, that's what I mean by manipulation. Rearrange the function, not change the function, just rearrange it, not a problem. The most difficult ones are the powers. These are the most difficult. I wouldn't say difficult, but cumbersome. Require a lot of work. Okay. I would like to look at something like this with fractions and natural log. Unless you want to choose something else, I'm fine with what you choose. Anyone? Well, I will choose 51 then. Thank you for the vote of confidence. X approaches 1, x over x minus 1 over natural log x. I have no idea where this is going with this problem. I have no clue. Okay, so when x approaches 1, this is 1 and this is 0. Problem, big problem. So I can't, at this point, even if I plug in, there is nothing I can do, right? And again, I have 1 over 0. So something needs to be done from the get-go, which means what? What do you think I am going to try or do first? What do you think? What would be the first? Assuming you don't have a limit, what would you think of doing?
You try to manipulate.
No, no. I have two fractions. What do I always do with two fractions? That's
Denominator?
exactly. Good. Can anyone, that's always the first thing, right? When I have two fractions, I try to find the least common denominator. Can anyone give us the least common denominator on this?
No, it's log natural x times x minus 1.
Oh, absolutely. This one does not have natural log,
Log.
and this one needs an x minus 1, right? This one needs a log because it doesn't have log in the denominator, and this one needs x minus 1 because it doesn't have x minus 1. Can anyone now give us the numerator?
Would it be x times ln of x?
Very good.
Minus 1.
Minus x, careful.
Plus 1.
Very good, awesome. Now, I want to see what this is all about. When x approaches 1, how much is natural log 1? We shouldn't be thinking about this, but that's okay. What is it?
0.
Yes, it's 0. Yes. How much is negative 1 plus 1?
0.
Excellent. Now, when x approaches 1, so this is 0. And how much is this?
0.
0.
Wonderful. I couldn't wish for better. By simply finding the least common denominator and changing, if you want to call it a manipulation, yes, I'm changing the outlook, but here I find the least common denominator. You can call that the same thing if you like. But by simply just performing this minor operation of finding the least common denominator, I got exactly what I was hoping for. That's all my wish. This is my wish. And this is my wish. Why? Because I have a very easy method to handle this. So let's move on and handle just that. So limit. Oh, I think that this is done. So limit as x approaches 1. Okay, so now I have to apply the product rule. So this is 1 and this is 2. So let's apply the product rule. First function prime is just 1. So I have natural log x plus x. Can anyone refresh our memory on how much is natural log prime?
1 over x.
That's it. And how much is negative x prime?
Negative 1.
How much is 1 prime?
0.
Excellent. Now here's a product again. I have to use number 1, number 2. First function prime, 1. times natural log x plus the first. Again, you already told me that natural log prime is 1 over x. Okay. I need to clean it up a little bit and then proceed. I can apply L'Hopital's rule 10 million times if it's needed, as long as it's 0 over 0 or infinity over infinity. Otherwise, I can't, not even once. Okay. You realize that this is x over x, which is 1. How much is 1 minus 1?
0.
Good. So then the numerator is just natural log x. The denominator is natural log x. How much is x times 1 over x? I'm distributing 1 over x to x, and then I will be distributing to -1. So how much is x times 1 over x?
X over x squared.
1, right? This is exactly the same thing. X times 1 over x.
Oh, sorry.
Right?
Yes.
Okay, and minus 1 over x. Now let's try again. Where does the top go?
0.
Good. Where does the denominator go?
0.
Excellent. Yay! I like it. So limit as x approaches 1, the derivative of the top. You already told me 1 over x.
X.
The denominator prime is 1 over x. 1 prime is 0. Now I have to be very careful. Please be careful on this one. Remember, we said, and I am kindly asking you to remember that this is -1 over x squared. We wrote it many times. So when I differentiate this, I get -1 over x squared, but there is a minus in front. So plus 1 over x squared. Good. So now limit as x approaches 1, the top is 1 over x. Can anyone tell us what will you factor out from this term and this term? I want to put it in front.
1 over x.
Excellent, brilliant, thank you very much, because I want to simplify this and make it as simple as possible. So 1 over x times what is 1 over x? What do I put here?
1.
Excellent, plus 1 over x times what is 1 over x squared? What do I put here?
1 over x.
That's it. Where does the numerator go?
1.
Perfect. Where does the denominator go?
2.
That's it. Excellent. 0 over 0. Would you have envisioned 1/2? No, because this is an indeterminate case. That's why we have to treat it as is. We have no clue. 0 over 0 and all the other ones mean no clue. Maybe I
So
should.
basically, like, after doing it once and then you still get an indeterminate case, you would have to do it again.
So what I mean by, forgive me one second, Isaac. By what I mean by indeterminate, I mean no clue. I have to investigate. Okay, say it again. I'm so sorry, I didn't catch what you said.
Like, since we got 0 over 0 before,
Yes.
you would have to do it the whole thing again. Like
Yes. So now I'm applying L'Hopital's rule from here. But now this is no longer 0 over 0. This is 1/2. If it's not 0 over 0 or infinity over infinity, I cannot apply the L'Hopital's rule again. So that's why at this point I'm asking myself, where does the top go? To 1. Where does the bottom go? To 2. So I'm done. As long as it's 0 over 0 or infinity over infinity, I can apply L'Hopital's rule. For anything else, I can't. Did I answer your question? I'm not sure.